of linear inequalities. Again, what's a system of linear inequalities? It's just when you have two or more inequalities together and you want to solve them at the same time. Okay? So just like what we're doing with system of equations. Now, there are two types of, for example, here you can see, if you look at here, example number one, there are two linear inequalities in two variables. And when it's written like this, just like in the system of equations, what we want is we want to solve these two inequalities at the same time. So we want a point, the value for x and the value for y, that makes these two inequalities true simultaneously. This is known as an AND type. Okay? This is an AND type, just like when we're doing in one variable, linear inequalities in one variable. It's just that we don't write the word AND, but it's understood that this is AND. There is also an idea of an OR type, that when you have an OR type, it will say OR. If it doesn't say OR, then it's AND. And we mostly consider AND type, so we just focus on this one. Okay? Once I show you how to solve these ones, then you're going to see that the OR type, basically you just chain everything together, because it's the union, right? As usual. So the interesting one is the AND type, because you have to figure out the intersection. So remember, AND means intersection. So you want to make sure that the point that you find is a solution. So the point satisfies all inequalities in the system. So it's a solution of both inequalities at the same time. Okay? The OR type is union. This is union. So that means that it only has to satisfy at least one of the inequalities. Okay? So that's why you combine everything. If it's good for this or this one, then it solves at least one. So that's part of the solution. But we are interested in AND, so you want to solve both at the same time. So if we want to solve both at the same time, what's the idea? Well, you solve the first one, then you solve the second one, and figure out what they have in common, and that's your solution. The same thing that we did for linear inequalities. Okay? The thing is that these are lines now, right? So these are two variables. So we're going to have a graph instead of having a number line, and we're going to have to do, the boundary line, shade the region. We're going to have one region shaded because of the first one, another region shaded because of the second one on the same picture, and we see where they overlap. Okay? So I'm going to show you once I do 1 and 2, then if I'm going to do 1, then I'm going to ask you to try 2 on your own, and then 3 and 4 are special cases. Okay? So I'll let you try those. Anyways, but we already have the knowledge to do it. Okay? It's just that instead of doing it once, we're going to do it twice on the same picture. That's all. So solution. Let's do number 1. So number 1, this is an AND type, okay, even though it doesn't say it. It will not be AND type if you see the word OR, okay? Otherwise, it's AND. Which means we need to intersect. So what do? We want to solve each of the inequalities, and then we put them on the same picture. So let's focus on the first one. The first inequality. Let's call this one number 1, and this one I'm going to call it number 2. So number 1, that's y greater than 1/2 x plus 1. Remember how we do this? The ghost is right. He knows we know, so it's taking his time. All right, so how do we solve this? This is an inequality in two variables. How do we solve it? First, we need to find the boundary line. What's the boundary line? Just put an equal sign here, okay? And graph that line. Once you graph the boundary line, you need to decide if it's a dotted or a solid line. Which one is this one? Is it a dash or a solid line?
A dash.
This one is a dash line.
How do we know it's dash?
Because of the symbol. If it's a strict inequality, if it doesn't have the little equal sign down, if you have the equal sign, it's solid. If it doesn't have it, like in this case, it's dash.
Just like open circle.
Exactly. So this means open circle. This is like the open circle case. All right. So we're going to graph the boundary line. That's the first thing that we do. So the boundary is the equation y equals 1/2 x plus 1. Okay, so here, this is already in a slope-intercept form, so this is ready to be graphed. So let's do it. Okay, so x and y. So let's see, the y-intercept, remember, to draw this line, we need 2 points. So the y-intercept is 1, so we have it right here. Here we have 1 point. That's good. And then For the other one, we're going to use the slope. Is the line going up or down? Up. So to find the next point, what do we do? One up, two to the right. Yes? So that would be 1, 2, and then 2 over here. So that's a point 2, 2. We have our 2 points. We draw a line. Remember, we need to draw a dashed line. Okay, good. So this is, let me put here that this is the boundary line for number 1. Okay, and then we need to decide what region is the solution, because remember, when you draw the boundary line, this divides the plane in 2 regions. This one and this one down here. How do we decide which one is a good one? Just use a test point, right? So for example, we can test the point 0, 0, because it doesn't pass through the point 0, 0. If the line passes through 0, 0, then we pick 0, 1, for example. Okay? So let's test 0, 0 on that inequality. So we plug it in and we see what happens. So what do we get?
You get 0.
We get the 0 is greater than 1/2. Remember, you have to plug into the inequality, not the equation. So we have a statement 0 greater than what? What do we get on the right? 1. So now you need to ask yourself, is this true or false?
False.
This is false. What does that mean?
No.
So it means that we need to check the region that does not contain 0, 0. So 0, 0 is down here, so this is the good place. So now, since you're doing this with pencil or pen, do the shading very, very lightly. Because you're going to have 2 different types of shadings in your drawing. So you have to do a very, very light shading. You will see why. Okay? In this case, I have the advantage of having this color, so it doesn't really matter because we use different colors. But in your case, if you're using pencil and so on, just do a very light shade. Okay. All right. So this right here is the solution for number 1. Now we're gonna repeat the same process for number 2, but we're gonna draw on the same pictures. Okay. All right. So let's do it. Are there any questions about number 1? All right. So number 2. This is x plus y less than 1. Again, repeat. So what do we need? Dash or solid? Dash. And now we need the boundary. What's the boundary equation?
X plus y equals 1.
X plus y equals to 1. You just need to draw this line. Now, to draw it, you are free to do it however you want. You can find 2 points and then draw it, or put it in a slope into a form so that you can just look at it and draw it. Like here is very easy. You just move the x to the other side, right? Negative x plus 1. So we can see the y-intercept is still 1, but this time the slope is, what's the slope? Negative 1. So is the line going up or down? Down. So let's do it. So my y-intercept is 1, and then I'm going to go down 1 and 1 to the right. Yes? So 1 down, 1 to the right. So right here, that's my other point. So we're going to draw our line. Dash line. Okay, so this is number 2. All right, so that's the boundary line for number 2. So right now, I know it may be a little bit strange, but try to ignore completely the old stuff that we did. Imagine that the red and the yellow thing that you see is not there, okay? You had a clean graph with your blue line on it. In other words, you have the blue line, now we have this portion over here, this portion down here. We need to decide which one of the 2 is, okay, for number 2. So how do we do that? Test point, right? So we can pick 0, 0 because it doesn't go to 0, 0. So let's test it. So when we plug in 0, 0, what do we get? We get 0 plus 0 less than 1. Yes? So that means 0 less than 1. What do you think about this? Is this true or false?
Very true.
This is true. So what does that mean?
Shade word 0, 0.
We need to change the portion that contains 0, 0. So, all right. So 0, 0 is here, so that means we should be shading under the blue line. Okay? I'm going to change colors. In your case, you do a very, very light shading. And then, since you're using the same pattern, like the same color, use a different pattern. What do I mean by that? If you shade, let's say that you have something like this. You will see why. Let's say that you have two lines, okay? And here, this line, for example, let's say that I shade like this. And then under this line, I'm going to shade like this. Like use a different pattern, so it looks different what you did, okay? And you will see why in a second. Anyways, here I'm going to shade under the blue. If you're using different colors, then it doesn't matter, okay? But if you're using the same color, then you should use a different pattern so you can see. So right now we have here the solution of both inequalities in this picture, okay? Our job is to decide what's the solution of our problem. Remember, our problem is a system, so we need to satisfy both inequalities at the same time. So what do you think we should be choosing from here?
A point in the shading that intersects.
The common shade, right? So what's the common shade? In this case, it's the region that turned green, right? By the way, notice that yellow and blue make green. But you see, the region that turned green, that's the one that we want. Because this portion right here is the one that works for the red and the blue. Do you understand this? So it has to be the intersection. So this one. That's why I'm telling you to use a different pattern. So you see where the two patterns meet. Okay? Like the two patterns that I did here meet over here. Okay? And then that one you do it very dark. Since everything is very light, if you don't want to erase it, ideally you should erase. But if you're doing pen, for example, you cannot erase, then the part that is the solution, then you do it very, very dark. So that when somebody looks at it, they know what you mean. So the point is that notice that whenever we have these two lines, there are four regions made. This will be region 1, region 2, region 3, and region 4. Well, in this case, region 2 is the solution, right? Because that's where they both meet. So this right here is the solution.
I have a question.
Yes.
What's the difference between it being false and it being true? Like the equation.
So again, if it's true, if when you put your test point, if you get a false statement, so remember. So let's look at number 1. You have this line. The line is called the boundary line because it divides the region, the plane, in two regions. This part above the line and this part below the line. One of the two regions is your solution. You just need to know which one is. Okay? To know which one is, and what we try to do is we pick a test point, and if that test point is a solution, then the region containing the point will be your region. If it's not, then it's the opposite. So we pick 0, 0 because 0, 0 is very easy to plug in. Yeah. So we pick 0, 0 because it's outside of the boundary, okay? And you put it. When I put it, I see that 0, 0 is not a solution for number 1. So that means this region here containing 0, 0, which is below the line, is not the good one. The good one is the other. So if you get false, you shade the opposite region. If you get true, like in the blue case, then that means that the region containing that test point is a good one, so you shade. Okay. That's. So you have your two shadings, and then take a look at where they meet, and that's your solution.
So when it's false, you shade the other region.
The opposite. But again, that's an individual basis. Then after that, you look at the entire thing, you see where they both meet, and that's your solution. Okay? That's for the AND type. If this would have been an OR type, what do you think the solution would be? If it was an OR type, if we had the word OR, if the problem would have looked like this, with an OR in here, in between the two, what would be the solution? The word would be exactly the same. You would do exactly the same thing. It's just that now everything that's shaded will be your solution. Just like what we did for the one variable case, because you take the union. Okay.
So everything but your section 4.
Exactly. So the solution will be in regions 1, 2, and 3. Everything that's shaded. Okay? Because it's okay for the blue or the red. So anything goes. This is the one that you have to avoid. That's if it was OR type. Okay? There could be something like that in the homework, but mostly I'm going to be asking you for AND type. Okay?
For the regions too?
The solution has to be a picture.
Oh.
This is the solution to that problem. The rest is the work needed to arrive to this picture. Okay? The solution is this picture with the shading. So technically, what you should do once you identify the region, technically what we do is, just for example, in this case, to avoid confusion, is we erase everything, or in my case, I will erase everything, and then I will just, shade this. And this is how a clean answer will look like. So, this is how a clean answer will look like. Because now we eliminated all the noise. Because the other regions, 1 and 3, they are noise because they do not work for both. 1 is okay for the red, that's not okay for the blue. 3 is okay for the blue, but not for the red. Only this one here works for both. So this is how the solution will look like. If you were doing it on pencil, then you should erase the leftover stuff, just to make it clear. Otherwise, you have to do something very dark, so people see that that's the region that you want.
Does the homework want to solve it with only one shaded section?
In the homework, it will look like this.
One shaded section.
You will see, it's the little, for example, let's see. Let's do one homework problem.
Yes, please, because I'm doing the homework and then.
Let's do one homework problem. No, this homework cannot be due today. Oh, the one that's due today is a system of equations.
Yeah.
That was the one that killed me. I was like, yeah, I know. Good. Well, I cried.
I cry every time.
No. Like,
I don't
that was the
understand.
first time the math, like that math work, just like happened. Good night.
You what?
I cried.
There are too many emotions involved.
Bro, math is
Math is
I don't like
so
math.
crying.
I will never like math.
Why
It's
cry?
so bad. Like, I think I have emotional.
And the fact that we're
trauma for-
forced to do math, like this has absolutely nothing with what I want to do in the future. Why
I've
do
been
I have to
traumatized
do
since
this?
the first day.
It trains your
No,
brain.
I'm not talking about
I feel like he's
this.
insulted.
Listen,
Look,
in my
man,
12
good job, useless. Like,
Listen, in my 12 years of school, you're the only teacher who actually makes me understand it. But why? Why do I have to do this?
Are you attacking this man?
I'm not
No,
attacking
No, I'm not being attacked.
years of school just to teach you.
It's,
I just complimented him. I told him that he's the only one that I have to
Inside this very
understand.
classroom, doing it.
So look, let's do this example. For example, let's do this example. For example. So, and this is recorded. So let's do it. So by the way, notice how this works. Okay. So in here, you have this little system, this little paddle. So let's see, which one of the two do you think we should be clicking for this?
Dash.
The one with the dash. You see? So let me make it bigger. You see, we should be clicking the one with the dash. And basically, to get the drawing done, what you need to do is you have to give the system the 2 points and make the line, as we normally find. And then you need to give it a third point. You will have to click on the region that you think should be shaded. Okay? That's what this means. So let's do the first one, number 1. Let's see, we can do it easily just by looking at it. For example, the line we're gonna test it because the y-intercept is 1, right? And the slope is 1, so that means this is the other point, right? 1 up, 1 to the right. So these are the 2 points from my dashed lines, 0,1 and 1,2. Everybody following this?
Yeah.
Now, which one should be? So let's test 0, 0. If I put 0, 0, does it work or not?
Yes.
We get 0 less than 1.
Oh, yeah.
That's a true statement. So the region containing 0, 0 is a good one. So I'm going to choose this one. Then I'm going to give 1 point. The other point, that's my, so I click it. You have to click it, okay? That's my boundary line, and now we need to give it a third point. Notice that if I go over here, it changes this. If I go over here, it changes this one, okay? Now,
Where did you get those points from?
You just saw that right?
How did you do that?
Yeah, like how did
the line is already,
Okay.
okay, the line is already in a slope-intercept form. So in order less than, think of it as y equals x plus 1. That's your boundary line. What's the y-intercept? 0,1, right? And then how did I get the other point? The slope. The slope is 1, so you do 1 up, 1 to the right. Yes?
Yeah.
Right over wrong. So you get this point, and we're using the dashed line. Now we tested 0, 0, and we saw that it works, so that means this region is a good one because 0, 0 is here, okay? So I'm just gonna click whatever you want here. For example, I'm gonna click 0, 0, but it doesn't matter. You can click any point you want. All right, so we have that. Now let's do the second one. Let's see, the second one. Dash or solid?
Dash.
dash. Now we need 2 points to draw the boundary line. Again, the same thing. So dash. So what's the y-intercept? -2. So we click there. Now, what's the other point?
Down 1 4 to the left.
So we need to go down 1 and 4 to the right.
Right.
So that will be a -3 down here and then 4. So right here. Everybody see that? So 4 comma -3. Right here. Yes? Now we need to decide, is it this part or is it this part? Okay? So let's see, which one is it? How do we decide which one is it? That's a point. You can use 0, 0. Let's put it in there. If you put 0, 0, what statement do we have? 0 greater than -2. Is that true or false?
False.
That's super true.
0 is greater than -2.
0 is bigger than -2. Yes?
Yeah.
So that means it will be this region right here, the one containing 0, 0. So I'm gonna go up.
It's not just true. It's super.
And just click whatever you want in there. Yes? Now, of course, in here you don't have the delete button, so this is what you will submit, okay? But let's say if you're gonna do it to me, what is the answer? Let's call it. Let's say this is region. Let's call this region 1, 2, 3, and 4. You see that there are 4 pieces here. Do you see the 4 pieces?
Yeah.
Which one do you think is the answer? The answer is region 1. Does everybody understand this?
Yeah.
This region. This is the one that works for both.
But
This is
it
the.
also goes to 4. So like
No,
how?
it doesn't go to 4.
Look at the lines. Look at the red
This
lines.
is blue.
Oh.
You see, it's between these 2 lines. This is the region.
Okay, I get it. Yeah.
All of this.
Yeah.
Okay?
I was thinking on it.
But when you're doing the homework, this is what you do because.
Wait, submit it, 'cause I wanna see.
and then it's-
Oh.
Yeah.
Alright. Here's
Super fast.
Do you understand this? Now, when you do it, I strongly encourage you, don't just click, click, click. Do it on paper. So in the exam, you're not gonna have click, click. You're gonna have a paper. So you have to do it, right? So do it on paper, so you get used to doing this kind of stuff, and then you know what to expect. So is that okay? All right. So okay, so that's that.
Literally. You might as well just click like that. You know, I'm done.
So let's see. Why don't you try number 2?
Would you?
Which is yeah.
Would you know?
Try number 2, and then we do it together. But remember, do it one at a time. Right now, just focus on number 1, and you wanna do that one. Once you have it done, then go to number 2 and repeat. Do it one at a time. Find your boundary line, graph that line, then decide the region by using a test point.
Do you do it in the original equation, like the one up there?
You always plug into linear inequality. The inequality, the one with the greater or less than.
Not from when you solve it, slope intercept. Like if I put.
No, put it on the original, because what if you made a mistake
Okay.
in solving it? So you always want to plug into the original as much as you can, because what if you made a mistake in your first step? Then
Wait, but can it be like either one? Like either
you're
one.
now working with number one. It's working number one. You don't look at number two at all. Number two is later.
Sorry, it's wrong.
Remember, this is not a system of equations. This is a system of inequalities. So what line should we use? Dash or solid? Dash. Okay. All right. So the boundary line, what's the equation? X minus 3y equals 3. Good. So now our job is to draw this line. Okay. How you draw it? Remember, it's up to you. If you want, you can find 2 points. You can find the x and the y intercept, which sometimes is very easy to do. Like in this case, very easy. Remember, to find x intercept, you make y equals 0. So you just ignore this, so x equals 3. To find the y intercept, you make x equals 0. So you ignore this, and so you get that negative 3y equals 3, so y is negative 1. Okay? So you have your 2 points, and then you draw. That's also, for example, like right here, if you don't like to deal with the slope intercept form, you can do it that way. In fact, I'm going to do it like that. That way you see different approaches. Okay? For example, I'm going to do it by finding the intercepts. X-intercept, I make y equals 0. So we get x minus 3 times 0 equals to 3. So x equals 3. Okay? Y, remember, I make x equals to 0. So that's 0 minus 3y equals 3. That's negative 3y equals 3. So y is negative 1. 3 over negative 3. So once you have the 2 points, that's all you need. You draw. And you don't have to worry about slope and all that business. So for example, here it's easy to do that. In the first one, for equation number 2 was nice to do it, but for equation number 1 it was already in a slope intercept form, and you have the fraction, so might as well just take advantage of it and use the slope. Okay. Okay, so okay, so let's draw the line. So as the x-intercept is x equal 3, so that's 1, 2, 3. It's right here. And then the y-intercept is negative 1, so it's right here. Draw your line. You just need 2 points. How you find it, that's up to you. All right, so dash. Now we need to decide what region needs to be shaded, right? Above or below. So How do we decide this? What do we need to do to decide what region to shade? Pick a test point. What test point can we use? 0, 0. Do you understand how to choose a test point? The only condition is that it cannot be on the line. So if the line doesn't pass through 0, 0, then pick that one because it's the easier one to plug in. It's very easy to plug in zeros. Okay. If it passes through 0, 0, the line, then pick something else, like 0, 1 or 1, 0. Stuff that's easy to plug in. Okay, 0, 0. We plug it in into the original, so we get 0 minus 3 times 0 greater than 3. Evaluate, so it will be 0 greater than 3. Is that true or false? This is a false statement. What does that mean?
You should be opposite.
So we shade the opposite. So let's see, I'm gonna use, you do it like this. Okay, so I'm gonna shade the opposite that region, that the one that does not contain the test point. All right, so that was number 1. Now we need to repeat the same process with number 2 on the same picture. Okay. All right. So number 2, write it down. Y less than negative 2x plus 4. For example, here this is already given to me in slow bit as a form, so might as well take advantage of that. Okay. So again, this will be dash. And then my boundary plus y equals negative 2x plus 4. So let's draw that. So the y-intercept is 4. So that's 1, 2, 3, 4. Then the slope is negative 2, so I need to go 2 down, 1 to the right, yes, to find the other point. So that will be here, 1, 2, and then draw. And need to do dash line. Okay, so that's number 2. And now we need to decide what region we want. Again, test point, so I'm going to use 0, 0 to test it. And when you do that, you get the statement 0 is less than negative 2 times 0 plus 4. So that means 0 is less than 4, right? So is this true or false?
True.
It's a true statement. So what does that mean?
Shade the region.
We shade the region containing 0, 0. So we have to shade down here, right? So shade this. Okay, so now that we have all the shadings done, we need to decide which one we need to keep. So what's the good region?
2. No, 4.
So let's call this, let's say this is 1, 2, 3, 4. Will be region 3, because you have to see where the shading overlap, where the red and the blue coincide. Hopefully you agree that that's in here. Yes? No, here there's only red. There is only red. So the overlapping is right here between these 2 lines, down here. Does everybody see that? So that's what you shade. So if you're doing it with a pencil, remember this is what you shade very dark. In my case, I use a highlight. It may be handy if you have a highlight. The problem is that then you're gonna erase it. But this way now we know this is the solution. Questions? Do you understand how to do this? Okay, so let's see. Do you have any questions from Tuesday's discussion, from Thursday's discussion? No questions? Okay, so as I announced on Thursday, the exam is going to be next week. Okay, so a week from today, in your case on Tuesday, we're gonna have test 2, and basically it covers everything we have discussed after test 1. So it will be module 3 and module 4. Let's see how it is laid out. Basically, sections 3 and 4 on my other math. Just show you this one. All right, so I move all the homework due by next Monday because the exam is on Tuesday, okay? And notice that there is another quiz. There was a quiz due yesterday, and there is a quiz that's due by Sunday. But before you attend this quiz, you have to complete homework 4.7, okay? So make sure that you do that before you attend the quiz. So module 2, the exam is about module 2, that's test 2. And it basically covers everything we have talked about: lines and system of equations and inequalities. So that will be chapter 3 and chapter 4. Okay? So everything that is in these two subfolders. So it's module 2. Okay? So it will be a week from today. And I will be putting a review on Blackboard. Once the review is available, I'll let you know so you can practice. But as usual, to prepare, the first thing that you should do is make sure that you complete all the homework. Okay? So that you understand what's going on. All right. So let's see. Last time I was talking about system of linear inequalities, and I actually did. We have these examples here. I did 1 and 2. Let's go ahead and do 3 and 4. That way we kind of practice what I discussed last time. So basically, the idea is, let me take a look at number 2 for a second. So just like when we're solving a system of equation, if you want to solve a system of inequalities, what you're trying to do is you want to find a value for x and a value for y that satisfies both inequalities at the same time. Okay. Now the point is that there are infinitely many solutions for number 1, as you know. There are infinitely many solutions for number 2. So we want to know among all of those how many or what are the ones that work for both of them simultaneously. So what do we do? Okay, just solve the first one. Remember how you do that. You need to draw the boundary line. That will be number 1. That's a red one. So you draw the boundary line. Just replace the inequality by an equal sign. Sketch the line and figure out what region works. In this case, it's the region below the line. Okay, that's the red shading part. Then you're gonna repeat the same thing for the other one. Okay, number 2. You draw your boundary line y equals -2x plus 4. That's the blue one. It's dashed because it's a strict inequality. Okay. And then you figure out what side of the line is a solution. In this case, it's also below the line, so it's everything that's shaded in blue. So now you have this in the same picture. Remember, our job is to solve both inequalities at the same time. So you want to make sure that the points that you pick, they work for number 1 and they work for number 2. So what does that mean? It means that in our picture, when you look at the shadings, you want to find what's common to both of them. Okay? So if you look at the red, it's everything down here. If you look at the blue, is everything down here. What do they have in common? This piece over here. That's where the shading overlap. Do you understand this? So this right here is the solution to the system. Any point on this area will solve the first and the second inequality at the same time. Okay? All right. Questions on how to do this? So basically, you just solve each inequality, by themselves, but on the same picture. And then look at it and shade the common region. That's all. Now, something that I didn't have time to finish last time is the following. In the first example that we did, this was the region that resulted. So this would be the shaded part. This is the final solution. Okay, the rest you can even erase it. What matters is what's shaded here. And it's important to understand what the region is. Here, the region is anything between these two lines, like this, not including the lines because of the shaded region. But this point is important because this is a little corner. And notice that the region goes all the way towards that point. So you need to know what this point is. In this case, we know it's 0,1, so there's nothing to do. So we understand the region completely. However, over here in this example, we can see the region in the picture, but as you can see, the region stops right here at this little point. But now it's not clear what this guy is. You see, it's not really on the x-axis, and we don't even know what it is. So this point, technically speaking, we need to find. Okay? Because once you find this point, then you know exactly what the region is. We know this line, that's the boundary line for number 1. We know this other line, boundary line for number 2. We need to know this point. Okay? So how do we find that point? Who can tell me? What do we need to do to be able to find that point? Anybody? But do you know that we allow you to figure out that point? You have a test in a week. So you should know an answer to this.
0 point.
Find this point.
Find that point with everything we have already.
Yeah, of course. How do you find that point? Let's see, what's special about this point? What can you say about this point that no other point has?
It's meeting the 2 lines.
Okay. And how do you find a point that meets 2 lines? What did we do last week?
Substitution and elimination.
And what was that for? What substitution and elimination? What is that for?
Systems of inequalities.
Of equation. And what happens when you're solving a system of equation? What is it that you're doing?
You're finding where the line intersects, the point where the line intersects.
Which is exactly the question here, right? We have 2 lines, they're crossing at a point. You want to know what point that is, or solve the system, right? We have an equation for the blue line. We have an equation for the red line. We see they're crossing at a point, so there's a solution to that system. Solve it and find the point. Do you understand this? Remember, when you solve the system of equations, you're trying to figure out do the 2 lines cross or not. And if they cross, where is it? That's a solution, the point of intersection, okay? So, to really complete this picture, now when you're doing the homework, it's not going to ask you for this, okay? But to really complete this picture, you need to know this guy. Otherwise, we don't really know what this region is. Okay? We don't know where it stops. It stops here, so we have to, or it begins here, however you want to look at it. And, you know, we need to know what that is. And to find it, solve the system. So, the point of intersection of the 2 boundary lines. So let's find it, that way we know exactly what the region is. And for that, we're going to solve the system of the 2 boundary equations. So equation number 1 is x minus 3y equals 3, boundary line. That's x minus 3y equals 3. And then the blue line, the blue boundary line is y equals negative 2x plus 4. Okay. So that's the equation for the first line. This is the equation for the second line. If we solve the system, we're going to find what that point is. Okay, now we need to decide what method to use. What do you want to use?
Substitution.
Substitution. Okay. So here we already have y solved for, right? It's very easy to put that into the first one. So I'm going to plug y equals negative 2x plus 4 into equation number 1. So that's 1, that's 2. All right, so it's going to give us x minus 3 times negative 2x plus 4 equals 3. And now we solve the equation. So let's see, what do we get here? That would be 6x minus 12. So that would be 7x equals 15. Moving the negative 12 to the other side, positive. So x is 15 over 7. Okay, so that's x. Okay, so once we know x, to find y, just go ahead and plug it in here, your x, and you can find your y. So to find y, we get that y is negative 2 times 15 over 7 plus 4. Now here you have 2 choices, okay? You either deal with the fraction by which, if you are comfortable with fractions, and at this point should be, you just compute this and you're done. Now, if you don't want to do that, what you can do is treat this as an equation, even though there's no variable here, the variable is on here. And then solve for y, meaning multiply everything by 7 to get rid of the denominator, okay? And then that's going to make your life probably easy. So I'm gonna do that so you can see. Okay. So what I'm gonna do is I'm gonna multiply everything by 7. So if I multiply both sides by 7, bring this down. Because when you solve a system, you're bound to find fractions. And when you find fractions, then what do? You need to know how to deal with that. So I'm going to multiply the entire equation by 7. So we're going to have 7y equals, now that means every single term. There are 3 terms in here, okay? When I multiply this term by 7, this 7 cancels with this 7 down here. Do you see that? So we're going to have, what do we get in there? What do we get? Negative 30. You have a negative 2 times 15 there. Do you see a negative 2? Yes? And there's a 15 here. So this 7 cancels with this 7. So they are gone. And then you get negative 2 times 15. These things are multiplying here. Do you understand this? They're multiplying. So you have negative 30 and then plus 28. Why 28? Because you do 7 times 4. Okay? And now we solve this. At least you don't have to deal with adding and multiplying and subtracting the fractions and so on. Okay, so this becomes negative 2, so y is negative 2 over 7. So we have our point. So the point of intersection is a point 15 over 7, comma, negative 2 over 7. So now we know what that is, so we put it over here. It's no longer a question mark. And notice that, this is consistent with what we expect. If you see, this is a tiny bit after the 2 mark. This is 1, this is 2, and the x value is a tiny bit after 2. That's exactly what happens. 15 divided by 7 is 2 point something, very close, right? It's 2 and 1/7. That's very close, so that makes sense. And then the y value is negative 2 over 7, so that's a very tiny number. That's negative 0 point something, very close to 0, and that's exactly what we can see here. Okay? So our picture matches our solution, at least visually. So that's good. I'm saying that because if you have this picture and then your x is, I don't know, 3/2, that's 1.5, that means that this point really should be somewhere in here. So you did something wrong. Either the lines are wrong or your point is wrong. Okay? So you always have to make sure that what you're computing makes sense. It agrees with what you have. Okay. Any questions? Do you understand this? Okay, so now this problem is really complete because now we know everything. Okay, we know the point of intersection and so on. Sometimes you don't have to find it, like I said. In this example, we didn't need to do that because we already knew this point. Okay, the point of intersection happens to be this one, which is the y-intercept of both lines, and it's a point 0, 1. We're good. Okay, but if the lines meet somewhere else, then you should find it. All right, so let's see. Let's do number 3. So that's 2y. Copy here. Okay, so that's number 3. So we're gonna solve this system of inequalities. Remember, you just treat them separately. It's just that when you graph them, you're gonna graph them on the same picture. Okay. So right now we're just gonna focus on number 1. We're gonna do it completely. Then we're gonna go to number 2 and repeat. Okay. So let's see. Number 1 as the inequality 2y less than or equal than 4. So to graph this, the first thing that we need to do is boundary line. So we need to figure out the boundary line. The boundary line is easy. All you have to do is replace the inequality by an equal sign. So that will be 2y equals 4. Okay, just put an equal sign here. All right, so let's see. Okay. The boundary line, is it going to be dashed or solid? Solid. It's going to be solid because it says less than or equal to, right? So we know this is going to be a solid line. Okay, good. And now, what type of line is this? We have 2y equals 4. Of course, the same thing as y equals 2, right? Just solving for y. There's no x. So what does that mean? What type of line is this? So how does it look? Let's see. Show me with your hand. Okay, that's called horizontal. Vertical is this. Okay, and standing vertically, we sleep horizontal. I'm saying because sometimes you guys, for some reason, you mix the words and then you pick the wrong stuff on the exam. Okay. Remember, when you lie to sleep, you are horizontal. When you're standing, you are vertical. So vertical is like this. Is x equals a number, that's vertical. Y equals a number, that's horizontal. Yes? All right, so that's a horizontal line. And where is it? Y equals 2, right? So our one is pretty straightforward to draw. So let's do it. That's x and y. 1, 2. And then we have, and then we do a solid line. Right here, 2. Okay, so that's our boundary line. Now we need to decide, notice that when you draw this line, it divides the plane in 2 regions, above and below. We need to see which one of the 2 is a good one. So, which one do we need to pick? What do we do now to decide which one is a good one? So how? Pick a test point, right? So we pick a test point. What test point? Whatever you want, as long as it's not on the line, whatever you want. You know, typically, if the line is not passing through 0, 0, pick that one because that one is very easy to plug in. Okay? So we're gonna test 0, 0. So test point, put 0, 0. Notice that here there is no x, so we plug in this into the original one, the original inequality. There is no x, that's fine, but y is equal to 0, so we have the statement 2 times 0 less than or equal than 4. Okay? Just plug in your test point and see if it's a solution or not. So what can you say? Is it a solution or not, the test point? So we are testing this guy right here. Is it a solution?
Yes.
It is a solution because this is a true statement. So what does that mean? What does that mean?
You shade where 0, 0 is.
And I shade the region that contains the test point. So we're going to shade down here. In your case, if you're using pencil, you should do a very light shading, okay? If you're not using pencil, okay, you use the highlighter. This is not the time to highlight. Because remember, we're going to be drawing 2 pictures on the same XY, and then you highlight what the final solution is. We are not going to take all of this as our solution. A piece of this will be our solution, okay? So, all right, so for the first one, this is what the first one says. The first inequality says anything below this line works. You okay with this? Now we're going to repeat with the second one, okay? Again, if you're using a pencil, just do it very lightly because then you will need to erase. Or then whatever the solution is, you do it very dark so it's clear what the solution will be. If you have it highlighted, that's perfect, but you have to leave it for the end. Okay, so number 2 is y less than or equal than x plus 1. Okay, so let's repeat. So step number 1, boundary line. So the boundary, how is it, solid or dashed? It's a solid line. Does everybody understand how to decide whether it's solid or dashed? Okay, so the boundary line is y equals x plus 1. Okay, let's draw it. Here we know everything, right? We know the y-intercept and we know the slope, so we can use that information. What's the y-intercept? 1. Okay, so it's going to give us 1 point on the line. And then using the slope, let's find another point. Who can tell me another point on the line? Well, 0, 0 is not on the line. Remember, we're still drawing the line. I need 2 points. We have 1 point, the y-intercept.
1, 2.
Let's find another one. 1, 2. Remember, the slope is equal to 1. So what you do is you go 1 up, 1 to the right. Yes? So it's going to give you 1, 2. Right here. And we draw a line. And once again, it's a solid line. Okay? And notice that we know this is the point of intersection, we know what it is, so we don't have to worry about solving the system like we did before. Okay? The point of intersection is 1, 2, so we know that already. All right, so while you do this, because we're doing number 2, you have to imagine that the red stuff is not there. Okay? Imagine that that's a clean graph, and we are only focusing on the blue stuff. Forget about the red stuff for now. Okay? So now you have the blue line, so it divides the plane into two regions, above and below. Okay, we need to pick which one is it. How? The same thing. Test point and see. Once again, the line doesn't go through 0, 0, so I'm going to use 0, 0 as my test point. I'm going to test 0, 0. Remember, always put it in the original one, okay, the inequality. So we're going to have 0 is less than or equal than 0 plus 1. So we end up with 0 less than or equal than 1. What do you think? Is this true or false? This is true. So what does that mean?
Shade the bottom, right?
We shade the bottom. So I'm going to shade all this. Yes? So anything below the blue line is okay for number 2. Anything below the red line is okay for number 1. Okay? Now, when you look at the two lines only, there are 4 regions now. I'm going to number them. Okay? Let's call this one region number 1. Let's call this one region number 2. Then this one will be region number 3. Then this one over here will be region number 4. So, between these two lines, that's number 1. Then this side is number 2, between the two lines. You see what I'm saying? And this is the other side, that's what I mean by number 3. And this is the other side, this right here. That's what I mean by number 4. So what do you tell me? Which one is the solution to the problem? In other words, where do the two regions meet?
1, 4.
Let's see. In region 1, I see blue shading. Do you see red shading in region 1? No. So 1 should not be part of the solution. Let's look at number 4. Do you see blue shading in number 4? Do you see red shading? So 4, they meet. Now, in number 3, do you see blue shading? So that's not good. And number 2, there's not shaded at all. So that means that one is not good for anybody. So this one says that this is okay for the second inequality, but it's not good for the first one. So we should not pick it because we need to solve both. Region 3 is okay for the first one, but it's not okay for the second one. So we don't pick that one. This one is the one that works for both of them. Okay? So because this is where the chains meet, that's what, now you can erase the rest. If you did it very lightly and you have an eraser, then what you can do is you can erase and then you shade this. You don't have to erase, but then make sure that this part you do it very dark. So it's clear that that's the solution and not anything else. Okay? That's why I was saying save the marker to the end, because at the end is when you want to check what the solution is. Any questions? So my advice to you is if you're using the same pencil, just use a different pattern when you're using the shading. I don't know, like if you shade one by doing this, then shade the other one by doing this kind of stuff. So you can notice when the things change and when they mix and so on. All right, so this is the solution right here. This region, okay? The solution is region 4. Okay, questions? Did you understand this? All right, try number 4. It's x less than or equal than 0, and then y less than 0. Number 4, x less than or equal than 0, and then y less than 0. Remember, focus on the first one, do it completely, then go to the second one and repeat. So remember, when you're picking your test point, it has to be a point that's not on the boundary. We typically pick 0, 0 because our lines are not going through 0, 0. If the line happens to go through 0, 0, you have to pick another point. Whatever you want, other than 0, 0, like 0, 1 or 1, 0, whatever you want. As long as it doesn't pass through 0, 0 and it's not on the line. Okay? Okay, anybody has a solution? Let's see, a solution for this one is special. It has a name, that region that you need to check. What did you check as your final answer? Let's see, you can even think about it. You don't even need to go through all of these things that we're doing to solve this problem. You can just think about it. For a point to solve this, one must the point satisfy. The x has to be negative, right? Or 0, and the y must be negative. What region is down in the plane? And both x and y are negative. It's quadrant 3. Yes? So once you're done with this, you have to end up with quadrant 3 shaded. That's what the solution is. For a point to satisfy this, x has to be negative or 0, so it's okay to be on the x-axis. And the y must be negative as well. So it forces it to be down here. So x, let's see, x negative, y negative. So we're talking about quadrant 3, this part over here. Do you understand this? So in this case, you can just think about it. And, you know, for these other cases, it's a little bit more complicated. So you have to draw and do all of this. But, you know, sometimes you can do it very quickly. In fact, if you notice, let me go back to our first discussion here. If you remember when we talked about, this is linear equations. It was some time ago. Okay, so linear equation, 2 variables. The very first thing that we did, I was talking about how to plot points and all of that business, right? We introduced coordinate system that I put x and y. It was even before this. Here. That we're plotting points and so on. You know, we introduced the coordinate system, and then how did I define the quadrants to you? I define it as a system of inequalities. You see, for example, quadrant 3 points here are those that satisfy these two conditions: x less than 0, y less than 0. Because the quadrant does not include the axis. So in our example, it's less than or equal than 0, so we need to include this part of the line. Okay? But you know, we define these things by using system of inequalities. Now, hopefully, it's a little bit more clear what I was writing here at that point. Okay? All right. Anyways, let's do it, but let's do it in a systematic way that we have been doing the others. Okay? Just to keep practicing. So again, number 1, that's x less than or equal than 0. So the first thing that we do is we need to figure out the boundary. And this boundary is solid. All right, so this is the equation x equals 0. What is this? What is this?
Vertical.
It's a vertical line. What line? This is special line. What is it? This line has a name.
Y.
It's the y-axis. Right? This is a special line. This is the equation of the y-axis. X equals 0. Right? So that's your y-axis. So I'm gonna draw it red. My y-axis, I'm gonna draw it solid and red. Okay? And for now, let's see, just looking ahead, because, so I don't have to erase later. And, number 2, notice that it's y less than 0, but when you look at the boundary, what is this? So it's going to be dash, right? And it happens to be, let's see, x equals 0, so that's that. Oh, sorry, you include the y, not the x. I was saying you include the x before. So that's the line y equals 0. What line is this? That's the x-axis. That's the horizontal line, and it happens at 0, so that's fancy. That's the equation of the x-axis. Now, the x-axis has to be dashed. So I'm going to draw it in this. Everyone understand why I'm drawing the x-axis dash? Do you understand this? Because of this. Okay? So it tells me that's a boundary line and it has to be dashed. And the y-axis is solid because that's a boundary line and it has to be solid. Okay, now let's return to number 1 and finish out. So we're going to use as our test point. What should I use? Let's see, who can tell me? What should I use as my test point? Even though you could do it at this point, because it says, if you think about x less than or equal than 0. So when you look at this is your boundary line. Where are the points that x is negative? So less than 0 on this side, right? So we better change this part of the line. But if you want to do the test point business, 0, 0 now is not good because this line passes through 0, 0. Okay? So let's get a point that doesn't pass through the boundary line. For example, I'm going to pick 1, 0. Okay? So I'm going to pick 1, 0. Just something that's outside of the boundary line. It's not on the line. When you plug in, we get the statement 1 less than or equal than 0. Is this true or false? This is false. So what does that mean? So 1, 0 is on this side. We got that it's false. So what does that mean? That this side over here is not good. The good one is the opposite one, right? So you shade this. Yes. Now go to the blue. Go number 2 and repeat. Again, you can do it straight from here already. It tells you y is less than 0. So this is your blue line, your blue boundary line. Is either above or below, because it's less than 0, then you know it's the one below. So there's really no need to go with the test point. But I'll do it anyways, just to keep the same thing that we have been doing. All right, once again, 0, 0 is not a good choice because our line passes through 0, 0. So I'm going to pick, for example, 0, 1. Okay? Again, 1, 0 is not good because our line also passes through 1, 0. Okay, so I'm going to pick 0, 1. All right, so when you plug it in, we get 1 less than 0. Again, that's false because 0, 1 is above the blue line. That means above is not good, so it has to be below. And now, hopefully, when you look at this, you agree that when the two shading overlap in quadrant 3. Yes? The blues and the red lines, this is the region that they have in common. Quadrant 3. So that's the solution. Okay, questions? Any questions? Do you understand how to solve system of inequalities? So this is essentially the last new topic for the exam. You okay with this? Okay, so now we're going to